Hello, welcome to Unit 2, Lessons 18, Representing Situations with Inequalities. This lesson is the introductory lesson to our inequalities part of this unit. The learning objective for this lesson is to be able to write inequalities that represent the constraints in a situation. Now, in the previous part of the unit, we've talked about how constraints are just kind of the limits that a situation puts into an equation. With equations, we were always saying that whatever our situation was had to be exactly equal to the constraint. But with inequalities, it's a little different. It's not just equal to, it could be less than or greater than as well. Let's take a look at activity 1. This activity is just a quick reminder of inequalities because I know it's been a while since you've done inequalities. So take a moment, pause the lesson, and try to do questions 1 through 4 on your own. All right, let's take a look at question 1. So question 1 is talking about h is greater than 50. So greater than 50. B is h is less than or equal to 50, or 20, sorry. And then C, we're saying 30 is greater than or equal to h. Question 2 says, is 25 a solution to any of these equalities? If so, which one? The answer is yes. It would be a solution to 30 is greater than or equal to h. Is 40 a solution? If so, which one? And the answer is no. It's not. 40 is not greater than 50. It is not less than or equal to 20. And 30 is not greater than or equal to 40. And then is 30 a solution? And in this one, it is yes. And again, it is 30 is greater than or equal to 30, right? It can be equal to itself. So we know that it fits in with the last inequality. All right, let's move on to activity 2. So activity 2, it reads as seniors in a student council of a high school are trying to come up with a budget for the senior ball. Here's some information they've gathered. Last year, 120 people attended. It was a success and is expected to be even bigger this year. Anywhere up to 200 people might attend. There needs to be at least one chaperone for every 20 students. The ticket price cannot exceed $20 per person, and the revenue from ticket sales needs to cover the cost of the meals and entertainment and also make a profit of at least $200 to be contributed towards the school. Here's some inequalities the seniors wrote about the situation. Each letter stands for one quantity in the situation. Determine what is meant by each letter. So your 4 inequalities are t is less than or equal to 20. 120 is less than or equal to p, which is less than or equal to 200. pt minus m is greater than or equal to 200. And c is greater than or equal to p over 20. Go ahead, pause the video, and tell me what P, T, M, and C all represent. So let's start with the letter T. I know for my inequality, T is less than or equal to 20. So that tells me that T, the ticket price, must be less than or equal to $20. Okay, P, so I can gather that P represents the number of people that are expected to attend. So P, number of people expected to attend. For the next one, we have PT. So this term is going to be basically how much they are going to collect in ticket sales. So amount collected in ticket sales. Whereas M is the cost of meals and entertainment. And then finally, C, this is the number of chaperones needed. All right, let's move on to activity 3. All right, this one talks about the constraints of an elevator. So an elevator car in the skyscraper can hold at most 15 people. For safety reasons, each car can carry a maximum of 1,500 kilograms. On average, an adult weighs 70 kilograms and a child weighs 35 kilograms. Assume that each person carries 4 kilograms of gear with them. So what question 1 wants you to do is write as many equations and inequalities that you can think of to represent the constraint of the situation. Make sure you're specifying what the letters represent and don't use letters Z, M, or G. For question 2, we're not going to really do, because obviously this is a video, so you can't do question 2, so you can just cross that out. Okay. So question 3, though, does ask you to rewrite your equations and inequalities so that they would work for a different building. I want you to complete question 1. So pause the video, complete question 1, and then unpause the video to go over question 1, and then do question 3. So I want you to make sure that you got question 1 down before you move on to question 3. So go ahead, pause the video, work on question 1. All right, so some possible inequalities. Now granted, you could have more or less than what I have, but I'm going to try to list as many as possible. So P is less than or equal to 15. And I'm saying P is the number of people in the elevator, number of people in elevator. Okay, another one that I could do is A plus C is less than or equal to 15. A is going to be the number of adults in elevator. And you guessed it, C is going to be the number of children in elevator. Another one that you could have is W is less than or equal to 1,500. In this case, W would be the weight in kilograms of the elevator car. So an equation that you could potentially write is W equals 70A plus 35C plus 4A plus 4C. You could have even combined 70A with 4A and 35 with 4C instead of writing it as one big inequality. You could also take part of this equation and turn it into an expression. So I'm going to write over here. You could say 70A plus, and actually I'm just going to go ahead and combine those. 74A plus 39C has to be less than or equal to 1,500. So those are all some potential inequalities and equations that you could write for this problem. So go ahead now, pause the video and go on to question 3. All right, let's take a look at question 3. So now it wants you to rewrite these equations and inequalities so that it would work for a different building where now you're kind of having some unknown constraints. So an elevator can hold at most 7 people. Each car can carry a maximum of m kilograms, and each person can carry g kilograms of gear. So I'm just going to rewrite my equation and inequalities as above, but inputting those new variables in place of the numbers. So P is going to be less than or equal to Z. A plus C is going to be less than or equal to Z. W is going to be less than or equal to M. You could also have W is equal to 70A plus 35C plus GA plus GC. You could also write that as 70A plus 35C plus GA plus GC is less than or equal to M. And you could even rewrite this as kind of using the distributive property. So 70 plus G times A plus 35 plus G times C is less than or equal to M. So some different options for writing those inequalities and equations. So I want to go back to question 1 real fast and talk about this inequality specifically. So I chose to write it as this, combining those like terms rather than this. So those two expressions are still equivalent to each other because we're using the idea of appropriate moves to create equivalent expressions, right? It just makes more sense to write it using fewer terms. It's a little bit more convenient, and it may allow us to gain certain insights about the situation. So when it comes to working with inequalities, there are some advantages and disadvantages for representing constraints as inequalities. Some advantages might be that compared to the written word, inequalities are simpler and quicker, a quicker way to describe what's happening. So instead of saying the weight of the elevator car it can be no more than 1,500 pounds, we would just write W is less than or equal 1,500. The number of people in an elevator car can be no more than 15. We just write that as P is less than or equal to 15. It's also easier to see what values a certain quantity could or could not take when the constraint is written with symbols and numbers. Some disadvantages, though, is that unless we know what the variables stand for, we can't really be sure about the meaning of the inequality. So in this case, that's why telling me what the variable represents is super important. And also, it can be a disadvantage because we may not recall what the symbols mean or how to read them, so it makes it difficult to access the information. So part of this is understanding what the less than, greater than, less than or equal to, greater than, equal to symbols represent. So some advice when writing inequalities to represent constraints, make sure that you are specifying the meaning of each variable. You're not using the same variable to represent different quantities. A lot of us like to use X and Y, which is fine, but we can't just continuously use X and Y over and over again within the same situation. Make sure that you're using the correct symbols and that they really do match the relationship. And using words to read in each inequality to make sure that it fully represents the constraint is also helpful. So don't just write the inequality, also think about and maybe read it out loud, like what does this represent? All right, so that's it for today's lesson. You're gonna go ahead and get started on the cool down. If you finish the cool down, remember you do have those check your understanding problems that you can complete as well. Thanks for watching.